Hello, this is Keith Tippman with Study Time Tutoring. Today's video, we're going to be going over pH. Additionally, we're going to be going over Ka and pKa, and then the difference between something with a low pH and a strong acid. All right, let's get started. So pH is a measure of hydrogen ions concentration in solution. So when the pH goes down, the hydrogen ion concentration is going to go up. And so when the hydrogen ion concentration is high, the solution is said to be acidic. So if we were, for example, to start with the hydrogen ion concentration in solution, all we would do is take the negative logarithm, because P in any value is simply the negative logarithm. So say, for example, if I had the hydrogen ion concentration in solution at, say, for example, 0.001 moles per liter. Another way I could write this is negative 1, 2, 3, 4, 10 to the negative 4 moles per liter. My pH would simply be 4. Now, if I had a hydrogen ion concentration of 0.001 moles per liter, or 10 to the negative 3, my pH would be 3. Now, one thing I want to point out, when the value of pH went down by 1, like say, for example, from 4 to 3, the hydrogen ion concentration went up by 10 times. So Ka is an equilibrium constant, specifically for acids. Now, it's going to tell me how many ions I can expect to dissolve into solution. So with a high value for Ka, I can expect the forward reaction to be pretty large. So therefore, I'm going to get more dissociation, and the compound itself is said to be a stronger acid. Now, you'll notice here that the values for pKa, which again is just a negative logarithm of Ka, are much more manageable than their Ka counterparts. So you'll see here that the values for Ka are either very large or really small. So we use pKa instead. Now, when we have a low value for pKa, we're going to get more dissociation. So keep in mind that they're inversely related. So a small value for pKa means we're going to have more dissociation, which again means the forward rate of the reaction is going to be relatively large. So this means that the concentration for the products, in this case hydrogen and chlorine, the concentration for these ions is going to be relatively large. Whereas the reactant, hydrochloric acid, the concentration of that is going to be relatively small. So with a big numerator and a small denominator, the value for Ka is going to be really large. So the compound, the hydrochloric acid or the hydrogen chloride, the compound is said to be a strong acid. Now, if we look at something with a larger pKa, we'll see that there is a forward and a considerable reverse reaction. Now, this means that there's going to be relatively fewer hydrogen ions in concentration, and the concentration of the conjugate base is also going to be proportionately smaller. So the concentration is going to go down, and the concentration is going to go down. Now, the original compound, the acetic acid, the concentration is going to be proportionally larger than we were looking at a strong acid like hydrochloric acid. So with a small numerator and a relatively large denominator, the values for Ka are going to be relatively small. So because the fact Ka is small and pKa are large, and the fact that there's going to be less dissociations, means that the compound acetic acid is going to be a weak acid because it's donating fewer hydrogen ions to solution. So let's do a quick review, and let's pay special attention to the differences between pH and pKa here. So pH is going to refer to the hydrogen ion concentration in solution. And so again, this is going to be on a logarithmic scale of 1 to 14. Now pKa is going to refer to a compound's ability to dissociate. So compounds that more readily dissociate are considered strong acids because they donate more protons to solution. But don't confuse strength for concentration. You could have a solution made up of weak acids, where the weak acid is in high concentration. So despite the fact that the weak acid is going to donate fewer hydrogen ions to solution, the concentration of H plus can still get pretty high. And so when you have a high hydrogen concentration, again, you're going to have a low pH. And so the solution is going to be pretty acidic, despite the fact it's made up of a compound that's called a quote-unquote weak acid. Now, alternatively, you could have a solution that is made up of a strong acid that is going to donate pretty much all of its hydrogen ions to solution, but the strong acid is pretty dilute. So the hydrogen ion concentration could be lower than the other solution that was very concentrated but made up of a weak acid. And so because the hydrogen ion concentration is low, the pH is higher, and the whole solution is considered less acidic, despite the fact it's made up of a strong acid. So that concludes today's lesson. So to test your mastery of the topics and numbers that we talked about today, there's going to be a link in the description to a few practice problems. If you have any questions, feel free to leave them in the comments section or email us at info@studytime.com. Thanks for watching today's video. Please consider liking and subscribing.